Welcome to another lecture. Here we will be studying about quadratic formula or discriminant formula. So quadratic equation is in the form of function of x equal to ax square plus bx plus c. So when we factor trinomial, sometimes it's not factorable. So there we use quadratic formula or discriminant formula. This lecture is divided into two parts. In the first part, we will be going over basics of quadratic formula. In the second part, we will be going over some questions. So first thing we have to see is the value of d. When d is greater than 0 or b square minus 4ac is greater than 0, then there are two distinct real roots. When d is equal to 0 or b square minus 4ac is equal to 0, then there is one repeated real root. When d is less than 0 or b square minus 4ac is less than 0, then there are no real roots. So before we step into the question, let's work on how we find the x1 and x2 value, which are the roots of the equation. Let's say you have found the value of d. Now the next step will be to use this formula. x1 is equal to negative b plus root d over 2a. x2 is equal to negative b minus root d over 2a. It's better to calculate the d value first and then substitute it here. Now let us jump into the second part of the lecture, where we will be going over some questions and concepts. So let us work on some questions using discriminant formula. Again, the quadratic equation is given as y equal to function of x equal to ax square plus bx plus c. Here b square minus 4ac is called discriminant. There are three scenarios: b square minus 4ac greater than 0. Then there are two real distinct roots: b square minus 4ac equal to 0, one repeated real root. The last one is b square minus 4ac less than 0. Then there are no real roots. So let us work on this question. Y is equal to 6x square minus 14x plus 8. So in order to find the roots, which are basically the x-intercepts in case of quadratic function, we will write it down as 6x square minus 14x plus 8 equal to 0. So it's in the form of ax square plus bx plus c equal to 0. Here a is equal to 6, b is equal to negative 14, c is equal to 8. Again, the discriminant formula is d equal to b square minus 4ac, negative 14 square minus 4 times 6 times 8. So d value is equal to 196 minus 192 equal to 4, that is greater than 0. So in this case, there will be two real distinct roots. The first one will be given by the formula of negative b plus root d over 2a, that is equal to negative times negative 14 plus root 4, discriminant value, over 2 times 6. On further solving it, x1 is equal to 14 plus 2 over 12, that is equal to 16 over 12, equal to 4 over 3. The second root, x2 is equal to negative b minus root d over 2a, that is equal to 14 minus 2 over 12. So 12 over 12 is 1. We have two values here, x1 equal to 4 by 3 and x2 equal to 1. So let us check our roots. 6x square minus 14x plus 8 equal to 0. We will substitute x equal to 4 by 3. So 6 times 4 by 3 square minus 14 times 4 by 3 plus 8. On solving it further, we will get 6 times 16 by 9 minus 56 by 3, which will change to negative 24 by 3 and plus 24 by 3, that is equal to 0. Checking our second root, 6x square minus 14x plus 8 equal to 0, x equal to 1. So 6 times 1 minus 14 times 1 plus 8, negative 8 plus 8 is equal to 0. Left hand side should always be equal to right hand side. That means our values are correct, and this is the way to check the roots. So let us work on second type of questions where we have to find the value of k, for which there is one real distinct root. X square plus kx plus 9 equal to 0. We have to find the value of k based on one distinct real root scenario. So a is equal to 1, b is equal to k, c is equal to 9. We will use the formula b square minus 4ac equal to 0. So b is k, so k square minus 4, a is 1, c is 9 equal to 0. So k square minus 36 equal to 0. So k square is equal to 36, k is equal to plus minus root 36. So k is equal to square root of root 36 plus minus 6. Another type of question, find values of k for which x square plus 4k plus k equal to 0 has two distinct real roots. So in this case, there are two distinct real roots, therefore d will be greater than 0. So x square plus 4x plus k equal to 0, a is 1, b is 4, c is equal to k. So d is greater than 0. So b square minus 4ac should be greater than 0. Rewriting the equation. So 4 square minus 4 times 1 times k is greater than 0. 16 minus 4k is greater than 0. Now what we are going to do is we are going to add 4k on both sides. So 16 is greater than 4k. Now we will divide both sides by 4, which is the coefficient. So 4 greater than k, and we can write it down as k less than 4. So in this case, all the values for k less than 4 will have two distinct real roots. Thanks for watching.